everyone, welcome to Physics by Aaryan. So I am very happy to welcome you all in this lecture. So we are doing free foundation physics course, and we started by our first topic, which is graphical analysis. In the first lecture, what we did is we did linear graphs, we did quadratic graphs, then we did parabola graph, and we did many sort of examples, and then we did the rational graphs. We did the power graphs like 1 by x square, 1 by x cube. How can you compare these kind of graphs and everything? Now we are moving towards more complex graphs. So number one function, which is little advanced function or complex function, is modulus function. In this lecture, we will start by starting our topic from modulus function. So what is modulus function as such? It's symbolized by two parallel lines and x in between. So you can clearly see what this modulus function do is makes the negative number positive. So if you do a mod of 2, you get answer 2. But if you do a mod of -2, still you get a 2. So what this function do is it ignores the negative sign and only takes the magnitude of the function. So how you can represent the modulus function? So if your power of x or the value of x is more than 0, so if x is greater than 0, then your modulus function is simply x. Why? So as I mentioned, if x is greater than 0, it means either x is 1, 2, 3, 4. So your mod of 2 will also be 2, mod of 3 will also be 3. So whatever is your value of x, that is your value of your function. So you can write your mod x is equals to x if your x is greater than 0. But if your x is less than 0, then your mod x is minus x. Why? So let's say your x is -2. So your mod x is -2, then your mod of -2 will be 2. So you can clearly see that your mod x is minus of x. So your answer which you are getting is minus of x. Okay. So when the x is greater than 0, your modulus function is x. If your x is less than 0, your modulus function is minus x. So this is what I want to tell you. Now, once you get this, then this is simply a linear equation, because y equals to x or y equals to minus x is simply a linear equation. So if you plot a linear equation on this graph, you will get a graph like this. You can clearly see, you can put the values of y, and you can clearly see that you will get a graph like this. Okay. So this is what I want to tell you. Okay. So this is how your modulus function graph looks like. Now, this is for y equals to mod x, and this is for y equals to mod x minus 1. So you can clearly see your x is shifted by how much? 1. Why? Because if x is 1, your y is 0. So your mean position is x equals to 1. So you will get a modulus function, but now the mean is not 0, but the mean is x equals to 1. So if you plot a graph for x minus 1 mod, you will get a graph like this, not like this. Similarly, if I plot a graph for mod x plus 1, you will get a graph like this. Okay, now, so graph like this. So your mean value will be plus 1. Oh, sorry, minus 1. Because at x equals to -1, your y will be 0. Okay. So this is how you make a modulus graph or modulus functions graph. So you should remember this formula first of all. Second, you should also remember the shape of the graph, because at many times you might need this in physics. So it is in a triangle kind of form. Next graph is exponential function. Now exponential function is a very important function in physics. We all know that. So exponential function means either fast growth or fast decay. We have heard many times in physics, it's an exponential growth or it's an exponential decay. So if your graph is y equals to e raised to x, then it is an exponential growth. Because if your x is increasing, your y is also increasing. And if it is y equals to minus x, then it is exponential decay. So because if your x is increasing, your y is decreasing. So let's plot a graph for y equals to minus x. First, let's plot it for minus x. So how do we plot the graph? Always start by plotting the graph by taking x equals to 0. So if I plot x equals to 0, I get y equals to e raised per 0, and anything raised per 0 is 1. And if you plot x equals to infinity, you get y equals to e raised per minus infinity, or you can say e raised per infinity, or you can say 1 by infinity. Anything raised per infinity is infinity. So you got 1 by infinity, which is 0. So your graph starts from 1 and goes to 0. So this is how your graph will look like. Very fast decay. Okay, so this is how your graph looks like. If I extend this graph in negative side, it will be like this. It will be like this. Why it is like this? Because if you see, if you put x equals to minus infinity, then what is your y? E raised per infinity, which is infinity. So if you take your x as minus infinity, your y will go to infinity. So this is what is happening in my graph. Now let's plot a graph for y equals to e raised per x. Again, if you put x equals to 0, you will get e raised per 0, and anything raised per 0 is 1. So your graph starts from 1. And if you put x equals to infinity, so I put x equals to infinity. So e raised per infinity is infinity. So as your x is infinity, going infinity, your y is also going to be infinity. Now, what about negative x-axis? So if I put x equals to minus infinity, your graph will become e raised per minus infinity, or e raised per infinity, or 1 by infinity, which is 0. So on the negative side, your graph goes to 0. So this will be your graph. So this is the kind of analysis you can do for an exponential graphs. Okay, so e raised per x is an exponential growth, e raised per minus x is an exponential decay. And this is how you can plot the graph. You can first take a value at x equals to 0, and then you can take a value at x equals to infinity or minus infinity, and you will get your graph. Let's move on to next part. Next is logarithmic function, log function. Now, exponential function was fast growth, fast decay. But what is logarithmic function? Logarithmic function is slow growth, slow decay. So whenever in physics there is a slow growth or there is a slow decay, we use log function. So there is a logarithmic decay. So your value of x is increasing too much, but your y is not increasing that much. So it's a very slow growth. For example, radioactive samples. Radioactive samples decay very slowly. They do not decay very quickly. So once you see, their half-life depends upon log. So you can see their half-life changes by log function. We will study this in nuclear physics. So you can actually see that your logarithmic functions are actually slow growth or slow decay. Now, there are two kinds of logarithmic functions that you might be aware of. Number one is natural log and other is log base 10. So natural log is represented by ln and base 10 log is represented by log. So in ln, the base is exponential and in log, the base is 10. So what does this base means? Base means if you do ln e raised per x, your ln e will be cancelled with each other and all you will be left is x. You can even do reverse. If you do e raised per ln x, so your e and ln will be cancelled out and what you will be remaining is x. So ln and e cancels each other. Similarly, you can see in base 10. Now, instead of e, if your base is 10 and you do log 10 raised per x, then log and 10 will cancel each other because the base is 10. So log and 10 will cancel each other and you will be remaining with x. In natural log, ln and e was cancelling each other because the base was e. But in this, log and 10 are cancelling each other because the base is 10. Similar thing you can do here. 10 raised per log x. So 10 and log will cancel each other and you will be remaining with x. Okay. So let's try to see. If I put ln e raised per 0, or you can say ln 1. Okay. E raised per 0 is 1. So ln e raised per 0 or ln 1 is simply what? Ln and e will cancel each other and you will be left with 0. That is why ln 1 is 0. So I will repeat this again. ln1 can be written as, so I can write here, ln1 can be written as ln e raised to 0. And now ln and e will cancel out. So you will be remaining with 0. That is why ln1 is 0. Similarly, what about ln e? So ln e can be written as ln e raised to 1. So ln and e will cancel out. So you will remaining with 1. So you can see ln e is 1. Okay, so let's move on to log side. If you see log 10, so log 10 means log 10 power 1. Log and 10 will cancel each other out and you will be remaining with 1. So log 10 is 1. But log 1 is 0. Why? Because 1 can be written as 10 raised to 0. And log and 10 will cancel out and you will get 0. So anything, log 1 or ln1, both are 0. Log 1 and ln1 both are 0. That you should remember. ln e is 1, but log 1 is 0. Okay. Oh, sorry. Log 10 is log ln e is 1 and log 10 is 1. Okay. So that you can easily prove all these four things very easily. But you should know a very clear difference between ln and log. Right. Now, there are some formulas for log, which are very important formulas in physics. These are used extensively at many places. What are these formulas? So log A plus log B is equal to log AB. What does it mean? If you take log 2 plus log 3, you will get log 2 multiplied by 3, which is log 6. So this is the first identity, very useful. Second, log A minus log B is log A by B. What does it mean? If you do log 2 minus log 3, you will get log of 2 divided by 3. Very important again. Now, third property is log A raised to B. So what you will do is you will take B outside the power and outside the log. So log A raised to B is B log A. Let's see this. So if you see this, minus 2 log 3. So I can take this thing and make the power inside, because this is B, and this is outside. I can take this B inside and make it a power. So if I make minus 2 as power, I will get log of 3 minus 2, or I will get a log of 1 by 9. So minus 2 log 3 is equivalent to log 1 by 9. Similarly, how I can write log 1 by x? So log 1 by x means log x minus 1. So I can take this minus 1 and bring it out. So I will get minus of log x. So log 1 by x is nothing but minus of log x, right? So this is the properties of log, and what is base 10 log and what is natural log. This you should remember, and you should understand this very clearly. Okay. I hope you are all able to understand. Next point. What about the graphs? What is a graph of log x? So if this is a graph of y equals to x, which is a linear growth, this is known as linear growth. And this is y equals to e raised to x, which is very fast growth. Then y equals to log x is a slow growth. You can see your graph is growing very slowly, very slowly. So this is your graph for y equals to log x. Okay, so that is what I want you to remember. Okay, so why I put like graph like this? Because if you see at 1, your y is log 1. So log 1 is 0. So your graph will start from here and it will grow like this. But the growth will be slow growth, and it will saturate after some time. It will saturate to some value at some point. So you have to represent a slow growth, then you use a log function. Similarly, if I plot two different log functions, one has a base 10 and one has a base 5. Both will start from here because log 1 is 0 for everywhere, every log function. So all will start from here, and log 10 will have this growth and log 5 will have this growth. So always remember, if base is less, growth will be little fast. So the base 5 will have fast growth and base 10 will have the slow growth. So that is why I plotted the two graphs like this. Okay, so this was all about log graphs. Okay, similar graphs will be seen in the exponential. Okay, now let's come to next part. So now here I do not want to teach you the trigonometry graphs because you all know the trigonometry graphs, but I have given these graphs in my notes. So you can go and see the notes on my course page or app. So you can clearly see the trigonometry notes there. You can read all the trigonometry graphs there and you will get enough idea that how sin x, cos x and hyperbolic functions are plotted. These things you can do by yourself because I do not want to teach sine and cos graphs to a undergraduate and graduate students who are very mature. So if you don't know or you need revision, you can revise it from my notes. What I want to discuss actually is applications of graphs in physics. So I will be discussing two graphs which are very important in physics, and this will give you an idea that how to plot a tricky functions, the functions which are not very easy to plot. So number one function is sin x by x. So whenever someone asks you, okay, what is I already mentioned this in last lecture as well, that what is a graph, how to plot the graph for this function. The first thing that you do is, okay, what is the value at x equals to 0? Now here I cannot answer because why? Because if you see, if I put 0 in numerator, I get sin 0, 0. And in denominator also I get 0. So whenever I get 0 by 0, it is an indeterminate form. Indeterminate form. So whenever I get indeterminate form, what I use is L'Hospital rule. I can use L'Hospital rule, and in that what I do is I differentiate numerator and denominator both. So if I differentiate numerator, I will get cos x, and if I differentiate denominator, I will get 1. So in numerator I have cos x, and in denominator I have 1. Now put the value of x as 0. So cos 0 is 1. So I got the value as 1. So at x equals to 0, my function is 1. So that is what exactly I'm doing. So at x equals to 0, my function is 1. Now how do I plot this now? Second thing I need to see is shape. So the shape will be sin x for sure because the graph has sin x in it. The normal sin x graph looks like this. It goes on like a wave. But now if you see, the amplitude of a sin x is 1 by x. I can write sin x by x as 1 by x times sin x. 1 by x is an amplitude of sin x. So you can clearly see, if I keep on increasing x, my amplitude of x will decrease, because if I increase x, my amplitude of x will decrease. So now my graph will not be normal graph, normal sine graph, but its amplitude will keep on decreasing. You can clearly see the amplitude of my sine curve is decreasing. Similarly, then on the negative side, the same thing is happening. So this is how you plot a tricky graphs. So you need to do some sort of tricks. So what is the trick I used here? I made 1 by x as an amplitude of sin x. And I said, okay, if I increase x, my amplitude will decrease. So my amplitude of sin x graph is decreasing. So I will get some graph like this. Now, if you remember, this is a diffraction pattern. In optics, if you have studied diffraction of light, then the diffraction pattern also has the same graph. So these kind of graphs you will see in optics. And this was also asked to me in an ISER Pune interview. So that I thought let's cover it in here. Okay. Next, second, electric field due to ring. So whenever we have a charged ring, let's say, and I ask you to find an electric field at point P on the axis, we will be doing this in class also, in electromagnetism class. The electric field which you will get is 1 by 4 pi epsilon naught qx divided by x square plus r square. So what is x? X is a distance, and what is r? R is a radius of the ring. So you can clearly see that your electric field is dependent upon x divided by x square plus r square 3 by 2. 1 by 4 pi is constant, Q is constant. So I took them out of the proportionality. So your electric field is proportional to X divided by X square plus R square power 3 by 2. Again, the same rule. See that what is the value of electric field at X equals to 0. So if you put X 0, you will get E0. Very good. You will get E0. What is the next step? One of the another feature of plotting the graph is finding maximas and minimas. So the question which I'm asking you is where means at what value of X, at what value of X, E will be maximum. X की कौन सी वैल्यू पे E maximum होगा? At what value of X, E will be maximum. So how do you solve this? So you do a derivative of E. If you do a derivative of E and make it 0, you will get the value of X where E will be maximum. So if you do a derivative of E, you will get this. You can easily do the differentiation, I guess. And if you make it equal to 0, you will get this equation. And from there, you will get X equals to R by under root 2. So the two major informations that I received is at X equals to 0, my electric field is 0. And at X equals to R by 2, my electric field is maximum. Max. So my electric field is max. Okay. Now let's plot this graph based on this information. So I will start my value from X equals to 0. I will increase my value till R by root 2. At this point, my electric field is maximum. It means after this, my electric field has to decrease. Yes. So my electric field has to decrease. I can make the same graph on negative side. So if you see, if you put X equals to minus X, what you will get is minus alpha X, X square plus R square root 3 by 2. So it is the same graph, but only in negative side. So on the negative side also, I will get a same graph. Only thing is it will be negative. So you see such a complicated function and we plotted this graph very easily. So these are the tricks that you can use. So what is the tricks I used? Number one trick is, what is the value at X equals to 0? Then you ask yourself, what is shape? If you don't know the shape, then find maximum minima. And if once you know maxima and minima, you can easily find the graph. I hope that you understood this, what I wanted to say. So let's move on to our last topic of graphical analysis, that is finding the maximas and minimas of the function. So many times in physics, some function is given to you and they ask you that what is the value, what is the maximum value of this function, or what is the minimum value of this function. Now, the first question that you can ask is, at what value of X? At what X? Your Y is maximum or minimum. So you are putting the different values of X and your Y is increasing or decreasing, whatever it is doing. So there will be some values of X where your Y will be maximum, and there will be some values of X where Y will be minimum. So how do you do this? So what you do is you find a derivative, as I mentioned I did it in the previous question also. So what you do is you take a derivative and make it 0. So if I do a derivative of x cube minus 3x plus 2, you will get 3x square minus 3x. Sorry, 3x square minus 3. And if you make it equals to 0, you will get x equals to plus minus 1. It means at x equals to plus minus 1, you have maximum or minimum. So when x is 1, you can have either maxima or minimum. And if x is minus 1, again, you can either have maxima or minimum. But I don't know, is this a maximum or a minimum? So I need to give a very definite answer, final answer. Ki my x equals to 1 is maximum or minimum. How do you do it then? So you do a differentiation one more time. So do a differentiation one more time. So if I do a differentiation of 3x square minus 3x one time more, what you will get is your double differentiation will be 6x. You can clearly see the differentiation of this function is 6x. Once you get 6x, put the value of your maximum and minimum. So we have 2 points of maximum minimum. One is x equals to 1 and other is x equals to minus 1. So put x equals to 1. So if I put x equals to 1, your double derivative will become 6. If your double derivative is more than 0, greater than 0, means it has positive value. It means you have minima there. That point is a minimum. If your value is greater than 0, it means your point is a minimum. And let's now put x equals to -1. If you put x equals to -1, your double derivative will be -6. So if your function is less than 0, it means you have maximum. So if your double derivative is more than 0, minima, and if your double derivative is less than 0, you have maximum. So what do we learn from here? X equals to 1 is a minima, and x equals to -1 is a maximum. So now we definitely know which point is maxima and which point is minimum. But what is a maximum and minimum value? So I said your y will be maximum at 1. Oh, sorry, at -1, and your y will be minimum at 1. But what is that maximum and minimum value? So to find the minimum and maximum value, what you do is you put the value of x in your function. So this is your function, just put the value of x here. So if I put my x as 1 in my function, I get 0. And if I put my x as -1 in my function, I get 4. So you can clearly see this is a minimum, and you can clearly see this is a maximum. So this is how you find the maxima and minima. And then you tell that which is maximum and which is minimum. And then you put a value in your function, and then you tell that what is a maximum value or what is a minimum value. So these are the 3 steps to find the maxima and minima question. So I hope that here I conclude graphical analysis topic. I hope that you understood this topic. Don't worry if you have not understood any concept, you can always comment in the comment section, either on my website or on the YouTube. On Sunday itself, I will be taking the live doubt class where you can ask me any doubt. So I will be clearing all your doubts. So tomorrow you will receive 2 more lectures, which are on the basis of basic mathematics I will be covering. So see you tomorrow. Have a good journey with Physics by Aaryan. Bye bye everyone.